morning. I'm going to talk a little bit about observability and hopefully how to make it a little bit easier to get started with it. My name is Daniel. You can find me on Mastodon. I've been doing software development for well over 20 years now. Let's not get into details. Currently working for Intellect. And as a bit of an agenda, I want to briefly talk about why I'm personally interested in this topic and why I think it's worthwhile. And then I'm going to go into a very, very short 101 on what I mean by observability. And then I'm going to showcase a little bit of a playground I built for myself to run experiments in and to experiment with tools. Kind of as a starting guide is, I think, it's my impression that a lot of developers, or the majority of developers, don't really care that much about DevOps. And observability falls well into that spectrum. And I think that's fine. Like, everybody has their own preferences and niches. But I'm hoping I can get maybe a few more people excited about this. Because I do think there is quite a bit of value in this. So for me, I'm talking a little bit about my history with this. Began a long time ago. There was this company, this streaming startup in Berlin, and they would host a lot of meetups and user groups. And I was in their office for user groups a couple of times. And I saw they had these dashboards on the walls or monitors on the walls. I don't remember the details exactly, but I've tried to recreate it. But it kind of stuck with me, right? Because as something that's immediately useful, right? Like, if you work on a streaming startup, you want to have something that shows you, here, this is what's currently going on. This are how many streams are being played. And I think, if you write an app, if you work on an app, if you work for a bank, wouldn't you want to know how many people are currently using the app, how many transactions happen today, or even like for something like Swift, wouldn't you want to know how many kilometers did people cycle today, or right? Stuff like that. So for me, this has always been a big motivating factor, is to learn a little bit about or get some feedback on how people actually use the software that I'm building, right? And not just develop into the void, but rather get a bit of feedback. The other thing I remember also from quite a while ago is a talk by Sam Newman on continuous delivery, I think when the book came out. And in the talk, he was, amongst other things, talking about Netflix and the way they were doing canary deployments. This, however, is not a canary, but I liked the attitude. And so, anyway, the basic idea was they would track some baseline metrics. This was still in the DVD days of Netflix, where they would track conversion rates, maybe how many people actually clicked through to put a DVD in the cart and hit send. And so then when they did new releases, they would roll out to 1% of the users, and they would compare the metric from those 1% of users to the baseline, and then if a certain threshold wasn't being met, they would automatically roll back the release. This has become a little bit more common today, but these days, but back then it was rightly lauded as being something pretty cool. And it also stuck with me as something very useful, right? Because it allows you to turn some of the quality conversations a little bit on their head. If you can talk about, or you can ask query it from different directions, right? Like, if we have bugs in our release, how quickly will we learn about it? And how can we make sure that the least amount of people are affected by it? So it gives you a little bit more ways of approaching quality. So both of these examples, I liked it. They're somewhat simplistic, but I think they already show the opportunities that are in observability tooling. But they also show one big problem, which is for statistically relevant data in your tooling, you need to actually have users and traffic. And so, yeah, like tracking 1% of your users isn't going to give you statistically relevant data if you don't actually have quite a bit more than 100 users in total. So these stories were, I think, from roughly around 2012. Right? So this is how Netflix looked like in late 2011. So I think, or I'm guessing that Netflix had to build quite a bit of the tooling themselves, had to put a lot of effort into gaining that capability. And thankfully these days, we're in a much better place. We have much more tooling there that we now can take for granted. And so hopefully we can have an easier time and don't need to put that much effort into making use of these tools. So I think, yeah, from a timeline, a lot of the things really are fairly recent, right? Even Prometheus was released at the end of 2012. Grafana came later, so a lot of the SaaS tooling came later. Yeah, we are in a better place because back then, I think mainly probably Nagios, Graphite, those kind of things, definitely a lot more effort. At which point, I take a short little break and make changes to my extremely contrived sample project. Yeah. And we can continue. Ta-da. All right. Yes. So, observability. What is meant by it? So generally, people talk about 3 building blocks: metrics, traces, logs. And they kind of differ in optimizing for certain things, making compromises for certain things. They also, the lines sometimes are maybe a little bit blurry. If you squint hard enough, everything is a log, but that's roughly the base. So metrics optimize for very high rate of events at the cost of having low cardinality. So for the data that you can correlate to it. So normally you think in you're tracking values over time. So gauges or counters. So you're either tracking a varying value or you're tracking a counter that continuously increases. So these are the classic kind of CPU load, rate of request to your web service, duration of request, those kind of things. But it could also be, yeah, like IoT devices, measurements, gaming, yeah, like I said, with cycling kilometers, whatever. Yeah, and then you can kind of, from counters and gauges, you can build distributions, histograms, that kind of stuff. And I like this as an example from the RubyGems public data set. It can immediately tell you things at a glance once you get a little bit used to this. From this, so it's a good example of we're aggregating data and we are segmenting it by a coarse-grained thing like the country in this case. And with the example of Germany and Japan, we can see in Japan the day starts a little bit earlier, and overall there is less people in Japan than in Germany, or at least less people downloading Ruby gems. And then you can also immediately recognize the weekends even without looking at the labels. And I like, in this case, when it works, like it immediately tells you something, and you can immediately also kind of, if you compare this week to week, you can immediately also notice if there's changes, if something got better or worse. Anyway, next up we have traces. So for a similar kind of comparable amount of money, you get you can handle slightly less events, but they supplement the metric data very nicely, right? So you're tracking durations across systems. Generally in this microservice world these days now, very useful. You have your incoming requests on your external gateway. Then you maybe trigger a bunch of microservices, maybe a few queue messages, a few calls to the database. And then you can dig into these as example requests and kind of look at in detail where the time is being spent. With a lot of the SaaS providers now, you also can integrate profiling data. So in theory, you can drill down to the library level, system call level, and yeah, really dig into where things are, where time is being spent. And then we all have the trusty old workhorse logs. But yeah, generally more expensive. If you think, yeah, Splunk, Elasticsearch, that kind of stuff, it's generally more expensive given the same amount of events, but you have the ability to have much more fine-grained correlated data that you can put together with that. But with the caveat and my pleading to ideally have structured logs and not do the logging that I grew up with, where you're just kind of pooping your log lines all over your code, scattershot, and to do then log-based debugging, right? Like entering method, save data, loaded the next one, exiting method, right? Like you don't want to do that. You want structured data that is easier to query, easier to aggregate, and then ideally one line per service per request, because that mixes in nicely with combining it with the tracing and metric data as well. So then in terms of, yeah, one question could be like, okay, which one should I choose? But like all three, I think are very valuable. And the more interesting question is, what questions do you want to ask, right? And so we can start with the more day-to-day operational type of questions of, yeah, like which systems have high load, where do we see a lot of errors, those kind of things, and alert based on that. These kind of things you get more or less for free with most of the tooling these days. So a lot of the stuff that's based on OpenTelemetry, and most of the SaaS providers in some way or another are that, give you tools that you can install alongside your deployables. So in many cases you don't even need to make changes to your code to get base level metrics of your HTTP in an outgoing request. There's quite a lot of AutoMagic these days that provides these things for you. So you can almost get these things, this kind of level of metrics for free. And then you can obviously build out from that and go a little bit higher and be slightly more proactive. Look at what can your metrics maybe tell you during the day instead of at 3 a.m. at night, right? If you know your disk is at the current rate of data that you're writing, that your disk is going to fill up in 2 weeks, then you can act on that at that point in time
and not at 3 a.m. in 2 weeks, when, like, why am I hearing about this now, right? So essentially the SLOs are kind of your disk filling up, I guess, for service level objectives, and air budgets work kind of in a similar way, I think. But it's also what I mentioned earlier in the comparison between like being able to compare and contrast and look for statistical deviations against your historical data. So that will also allow you to be a little bit more informed on what is going on. This is also in most of the SaaS tooling now actually has support for this as well. And so then highest level questions is, for me, where I think it becomes really interesting is when we're looking at stuff that maybe normally falls more into the business intelligence space, like data analytics kind of space, which is the better place for some of these things. If you're running lots of ad hoc queries, lots of detailed analysis of your customers, then that's all fine. But if you notice that there's certain questions or certain queries that you run all the time, that you're interested in all the time, then have a look. Is there a way that we can emit these kind of data points directly from our code as metrics or log entries? And so to enable you to be able to answer those kind of questions in real time, and probably also cheaper than with BI tools. Yeah, but for me that's can be quite interesting, right? So what it does require is, so you have a lot of questions, but what it does require you to kind of, the further you go, you do need to have a bit of an understanding what do the different tools do, what can the different tools do, how do I best make use of that, which things are maybe geared towards other things, like to be able to play around with this. And to be able to play around with this, you can kind of, anything you can download, have a little sample app, but if you just kind of hit F5, you're not generating all that much interesting traffic that you can graph out, right? And so in my case, I then built something with the help of K6, which is a load testing tool, to create some baseline traffic to allow me to experiment a little bit more with this. For this sample project, I had 3 basic goals for myself. First of all, I wanted some base web app that was actively being maintained that I didn't need to worry about. And so I chose the Spring Pet Clinic project because it is actively maintained by the Spring project, and I know Spring fairly well, so that made sense. I wanted it to run locally, so it's in Docker Compose. In theory, I think this sample project also makes sense to tie in with any of the SaaS providers. In my case, I wanted something that was self-contained. But I think, yeah, there's no reason why it couldn't be also tied to one of the SaaS tooling. And then I wanted something that was also hopefully somewhat self-updating, self-correcting, or at least letting me know if things didn't work anymore. Because what I noticed was any kind of sample project you look at for any kind of tool, you find GitHub sample projects for everything, and usually they all don't work. And which is understandable and perfectly fine, right? You have your little sample project, you play around with it, you upload it to GitHub, and then you never look at it again. I think that's fine. And the other good thing also is there's a lot of movement in this space, a lot of quick development in the tooling. And so things break, so that's fine. So I'm trying to have the project maintain itself a little bit to help with that. So maybe to look at that. So in this case, it's a bit of GitHub action that kind of rebuild, check out everything, and Docker Compose just uses the latest versions, and then the hope is that in the end, my tiny little test script will let me know if something does break. It has already worked 1.5 times, so maybe the project will not go immediately stale. That's the hope. Yeah, in terms of the pieces, it's a Spring app with a Postgres backing. Postgres, I've artificially constrained the CPU processing power of the database for my very contrived example. Yeah, so then we have the app, we log metrics through Prometheus, the rest is Grafana tools. We have Grafana itself for the dashboard, Tempo for traces, Promtail to forward log files, to Loki, which is a log file storage and querying tool from Grafana, and then we have the configuration for K6 as well. K6, if you're familiar with Playwright or WebDriver, Selenium type tools, it shouldn't be too unfamiliar. In our case, we are accessing two different sites or two different pages. Maybe I can just show this. So the Spring Pet Clinic project is very a simple website just to showcase some Spring features, and yeah, you can book appointments for your pets. Anyway, so we are specifically looking at the landing page and the owner search page. So one of the pages does access the database, the other one doesn't. And yeah, and then within K6 you have quite a few different executor options of like specifying how you generate traffic. In our case, we ramp up to 800 requests per second, run that for a minute and then ramp down again. And I think I forgot something, but doesn't matter. Realizing now, I wanted to show something, but that should still be fine. Anyway, so now, then you end up in Grafana. Yeah, this build big enough. So Grafana on their website offer you a lot of dashboards pre-made for various tools and frameworks and languages, varying quality, also varying up-to-dateness. On a meta level, there is actually also a dashboard for the K6 test runner itself. But, excuse me. In our case, specifically, we're caring about Spring Boot. So there's a pre-built dashboard for Spring Boot, which already showcases one big problem that a lot of the SaaS providers also have, which is kind of information overload, right? This is only, I mean, it's zoomed in pretty much, and it's already too much information anyway, to some extent, right? Yeah, so like I think overall, if you have the chance to kind of familiarize yourself better, eventually to come to a point where you can kind of purpose-build dashboards to specific things that you want to look at, I think makes a lot of sense. In this example, we're going to roll with it, yeah. One other thing is, and that's the one I forgot to do the second time, but anyway, you can, through the command line with curl, you can send API requests to Grafana to do these little annotations here. Yeah, I wanted to do one before the second run, but it's fine. So, essentially what happened before I started talking, I started the first run, and then in the popcorn break, I started the second run after tweaking some settings. And you can, from the load average, you can immediately see that the second one was worse, or made things worse. And specifically, because we are talking about, or I already said we're talking about a database problem. In this particular case, where in many cases this might be too much information or not necessarily relevant, but in our particular case, this is actually relevant. So in the second example, I increased the available connection count for the web server from 2 to 20 connections, and that made things significantly worse, which I already found interesting. I'll get to it in a minute. So we can see here from the 2 runs, the requests ramp up to 800 requests per second, and then ramp down again, and the second run. In the number of requests, it's somewhat comparable, fairly comparable, but if we look at the response times, then we see the response times increase for the page load that had the database query, in line with the increase in overall concurrent requests. But we can see that it's much, much worse in the second run through. So I like this. It's like I said, it's a fairly contrived example, but I liked it because it wasn't exactly what I was expecting. After thinking about it for a while, it makes sense. The constraint is the database. Just having more connections open to it is not going to make things any better. But when I was initially just tweaking the connection parameters and playing around with the settings, I was still a little bit surprised. And so kind of like having a bit of dose of reality in how do different settings affect things was already kind of useful and interesting to me. And then I wanted to show specifically, we can do this a little bit bigger, specifically histograms, just as a very nice thing, because you can show 2 values at the same time, right? You have the y-axis is the latency, so your normal value, but the brightness tells you the number in that bucket. So you can see that across both of these test runs, there's one large group of very quick responses, and then there's a growing cloud of responses that gets slower and slower. And we can then see that it's much more pronounced for in the second case, right? And this kind of makes sense. And then at this point, we can turn on exemplars. So this is a fairly recent feature from Prometheus, where you can combine metrics with trace data, right? So in a particular subset of response time, in this case, we can look at sample requests within that space, right? So we can look at here maybe one of the more unproblematic requests, and then we can look at one of the extremes over here as in comparison. And so for the normal request, it finishes in 2 milliseconds, all fine. We can see the database connection and the subqueries, including the query templates. And this is normal. And if you had microservices, other services that you called, those could show up here as well. And then in the second case, we see most of the queries are kind of quick, except for outliers. But the really big problem is that it takes almost a second to get a connection, right? And so individually, also not super interesting, but it is useful. Like the specific problem, I think, becomes obvious from this as well, right? Like if you look at it, where's the time being spent? The time is being spent not doing anything, waiting to run the queries. And then from here, we can go to related logs. There was a way to close this. We can look at related logs. So log files with the same trace ID. These come out of Loki. It's not particularly interesting what's logged here because I'm not actually making I'm just checking out and always rebuilding the Petlinic project. So I'm not having, I don't have my own logging in there. I just added a logging library to do basic HTTP kind of Apache log type logging. But I think it still hopefully serves as a way to illustrate that you can then cross-reference these things back and forth with each other. Right? That is that. I want to then quickly point to Honeycomb and Grafana Labs, specifically for their website, because they have, I mean, all of them have tooling, but I like, so Honeycomb has good webinars, good tutorials, and specifically they also have sandboxes with kind of sample data that fulfills somewhat of a similar need, where you can play around and they walk you through tutorials of how to use their tooling. In particular, I like they have a feature where you can look at heat maps again, so this is how they would look in Honeycomb, and then you can do kind of a comparison, what is different in the related dimensions of related context data, what is different to the baseline. And I find this like a fairly nice way of approaching this. Other tools, Datadog has something that's, I think, correlation, something or other analysis. So to some extent, all of the SAS tooling does more or less the same things. I just quite like how this looks. And for Grafana as well, they have a Play website as well, where they showcase some of the different options of how to graph things. And they also have very good documentation and tutorials. I've put up a blog post with slides and related links also to that. And yeah, I think that's it from me for my planned excursion. At this point, I'm happy to show more, go into any examples. I can talk a little bit about Open Rewrite in terms of how I automatically update the Spring Petlinic project, and otherwise I'm happy to answer questions or requests. Thank you for your time. The tricky part is, so just to repeat the question, so like how would you store data over a long time to be able to run historical analysis on this? So the tricky question is, how do you do that without spending insane amounts of money? And that is, I think, where things optimize for different things, right? Prometheus, for example, specifically has this concept of federation, where you essentially set it up to aggregate data over time. So you wouldn't store all of the data, but you would have one Prometheus data that captures your live traffic for a week, and then you would have another Prometheus server that would then aggregate that data and store that for a longer period of time. That's how I've seen that more commonly done. And then with the SaaS providers, there is option in terms of, like they do have tiered pricing of, and yeah, it kind of depends on what you're going, but from what I remember, like Datadog has something for this, pretty sure Honeycomb as well, pretty sure Dynatrace as well. So some way of approaching how can I store data in long-term storage, and maybe I do sampling. So sampling works reasonably well for a lot of the things. And then you can also kind of filter out a little bit
right? You don't need tracing data. You probably don't need all much old stuff. And log files you can put on Glacier, like kind of type storage. Loki, I think specifically also has options for it. Anyway, I can ramble about this forever. Any other? I hope this is helpful. All right, thanks.